everyone. Good day. So I will be sending you two playlists. The first playlist is this one focused on the review only, and then the second one will be focused on the answering problem solving, no? Answering problem solving tayo. Okay, para nice. Now, before we proceed, in the past we discussed that there are different types of forces. Meron tayong dalawa, no? So, contact forces and non-contact forces. Very simple. When you say contact forces, it requires interaction between two objects or two different bodies, no? Non-contact forces is dili necessary nga naa sila kuan. Dili necessary nga naa sila contact, but rather pwede ra na sila interaction despite of its distance, no? Now, in this case, we also discussed the free body diagram. So the first part of a free body diagram is, please do not forget, is really to draw. After you draw, you can now create the FBD starting with the Cartesian coordinate system, and then you write all of the forces acting in either X or the Y axis. The FBD is very, very important because this will guide you in making your expression later so that makabalo mo what are the forces acting on the X, what are the forces acting on the Y, nga dili siya magkabaliktad-baliktad. Okay? We also have here another example. So, in this case, natay, ano din ni, ano, natay, book F sub n ang iyahang normal force. Do not forget that normal force is there if the object is in contact with another object or is in contact with the surface. In this case, the book is in contact with the surface of the table. That is why makakita mo din na ang naa siya ay normal force. Okay. In this case, we also discussed that the mass and the weight, they differ in terms of their nature. When you say mass kasi, mass is something that is innate in a body. So example, in this case, we have 50 kilogram mass, and the 50 kilogram mass is on planet Earth, which is acceleration due to gravity 9.8 meters per second squared. And if we get the weight, since weight is the result of the interaction of gravitational force to the mass, we will now have 50 times 9.8, that is basically 490. Then you have kilogram times meter per second squared, that is newtons. So the 50 kilogram mass on Earth has a weight of 490 newtons. But if we're going to get or to bring this the same mass in planet Benton with an acceleration due to gravity of 5 meters per second, it still will have 50 kilogram mass. But the difference is lahi na ang iyahang weight. Gano man siya. In this case, you have now 50 times 5, so that is 250, and then kilogram times meter per second squared, that is now newton. So in this case, we have the same mass, the same body, but you have now different weight. Kasi nga, weight is simply the result of the interaction of the acceleration due to if the of the interaction of the gravity to the mass of an object in that particular heavenly body. In this case, we have planet Earth and planet Benton. So, we also discussed in our previous sessions the three laws of Newton, which is basically we reviewed your knowledge in grade 8, and that will be used in our discussion for grade 12. Okay, so in this case, we have here an example, no? Nay nagbangga nga kuan nga sakyanan. So nagbangga siya nga sakyanan. Now, the law of inertia is basically focused on the inertia of a particular body. So we discussed last time that the bigger the mass, mas dako po ang yang inertia. Now, in our layman's term, we term inertia as the laziness of something. So if an object is moving, that object is too lazy to stop. But if the object is not moving, so it's too lazy to move. That's why we have the inertia. Another example is a bicycle and pison. Saan ang pison? Dump truck na lang. Dump truck. Ana. So the bicycle and the dump truck, lahi-lahi silag mass. Therefore, si dump truck kay dako man siyang mass. So kung wala siya naglihok, lisod siya palihokon. Pero kung nag-move na pud si dump truck, lisod pud siya ipastop. So ingana na siya no. So the bigger or the more massive a body is, dugay pud siya palihokon or dugay siya pa stop o palihok, no? So ana siya. Now in this case we have here Newton's first law of motion is also called the law of inertia, which states that an object at rest will remain at rest and that an object in motion will remain in motion along a straight line at a constant speed unless acted upon by an unbalanced external forces. Now, take note that inertia is the tendency of an object to remain at rest or to remain in uniform motion along a straight line. So what's happening here? For example, if an object is not moving, that is obviously under the law of inertia kasi nga, it's not moving. But if you will try to push that object, mulihok siya gamay, there is a change in the velocity. And if there is a change in the velocity or speed, there is a change in the acceleration. And since there is a change in the acceleration, or if there is an acceleration, buot pasabot, under na siya sa second law of motion. Pero, if that particular object will move with constant velocity or constant speed, mabalik na pud siya sa law of inertia. So wala naglihok, law of inertia. Gituklod nimo, nilihok, nay acceleration, second law of acceleration. Pero ni move na pud siya with constant speed, balik na pud dayon siya sa law of inertia. So yung ana lang siya basically no, ang idea ani. Now, in this case, we have examples dalawa no, a basketball and we have a tennis ball. Tennis ball ba ni? Mura. A basketball and tennis ball, they are allowed to roll from the same height, no? Tapos upat ka buok bottles of water ang iyahang sa ba giagian sa gidaganan or whatever. So magkataas po ng iyang impact it's sa basketball. It's because the basketball is massive compared to your baseball. Baseball ba ni? Tennis ball man siguro ni. Oh, feeling na ako murag tennis ball. So, in this case, lisod i-stop si basketball tungod kay massive man siya. So, mas taas siya og inertia. Buot pasabot, kung naglihok na ang imuhang basketball, lisod siya i-stop. Kay taas man siya og inertia. So, ingan lang siya. And the effect is, mas dako po siyang effect sa atong mga water bottles. Okay? Now, in here, we have here the questions like, what is the reaction of your body kung wala naglihok ang bus niya, mukalit rag lihok mudagan ang bus, or baliktad, mukalit rag brake ang bus, what is the reaction of your body? So lahi-lahi siya, di ba? So the passengers tend to move forward when the bus suddenly stops. Nga naman, because your body is on the bus. And since the bus is constantly moving, unya ni kalitra og brake ang driver, so ang imong body will resist the movement, will resist the motion nga nag-ingon nga nag-ingon, the motion nga katong pag-brake ni driver mo resist imong body sa mo na mo move forward ka. So baliktad po siya, if the bus is not moving nya mo kalitra og kuan dagan ang bus, so your body will also move backward ngano man kay ang imong body kay will resist man the motion kay gusto man siya nga nara sa didto sa iyahang moment. So basta mao lang na inyong timailhan, a law of inertia gali, if the body is not moving, dili siya ganahan mo move. Pero if the body is moving, dili po siya ganahan mo stop. So, mo na siyang law of inertia. So, as the bus moves, the passenger moves as well. And if the bus suddenly stops, the passengers tend to remain in motion. So, they lean forward. When the bus suddenly speeds up, the passengers lean backward because they tend to remain at rest and resist the movement. That is also the same in this trick nga kana ganing katong akong gipakita sa inyo sa class nga kanang naay object tapos naay cloth sa ilalom then kwaon nimo ang cloth without the sa kanang dili siya mga bali ng mga butang nga naa dinha sa babaw. So that is also an example of the first law of motion.